Hello everyone, in this video we will start exercise 1.2 chapter 1, that is number system, real numbers, class 10. So question number 1 is express each number as product of its prime factors. So part 1 we have 140. So we need to represent 140 as product of its primes. So 140 is also a composite number. So the fundamental theorem of arithmetic says every composite number can be written as the product of its primes. So we will do the prime factorization of this 140. So 140 can be written as 2 and 70. 70 is another again a composite number, so we can do the prime factorization again. So 70 can be written as 2 into 35. So 2 is prime number and 35 is a composite number again. So 35, this composite number, can be again factorized into two prime numbers, that is 5 and 7. So here we have prime factors as 2, 2, 5, 7. So this order of these primes doesn't matter. We can start from here 7, 2, 2, 5. We can start from 5, 2, 2, 7. We can start from 7, 2, 5, 7. Order doesn't matter. Keep in mind, fundamental theorem of arithmetic says order doesn't matter. Keep in mind. So prime factorization of 140 are 2 into 2 into 5 into 7. So 140 equals to 2 square. As you can see, 2 into 2 becomes 2 square into 5 into 7. So these are the prime factors of 140. In the next part, we have give it number as 156. So do the prime factorization of 156. So 2 into 78. 156 can be written as 2 into 78. Now 78 can be written as 2 into 39. And 39 can be written as 3 into 13. So now we have 2, 2, 3 and 13 as prime factors. So prime factor of 156 are 2 into 2 into 3 into 13. So now 2 into 2 becomes 2 square into 3 into 13. So these are the prime factors of 156. So proceed for the next part. 3825. 3825 is the next number. So 3825. As this is an odd number, so we can divide it by 305. Let us check. But we need not to check whether it is divisible by 3 or whether it is divisible by 5. As the last digit is 5. So I am dividing it by 5 first. So 3825 can be written as 5 into 765. Again we can see the last digit is 5. So we can divide it by again 5. So 760 divided by 5 becomes 153. So now we will divide it by 3. You can see 5 plus 3, 8 plus 1, 9. So sum of this digit is 9, that is divisible by 3. So 153 is divisible by 3. So we will divide 153 by 3 and it becomes 51. So 153 can be written as 3 into 51. And then 51 can be written as 3 into 17. So now we have 5, 5, 3, 3 and 17 as prime factors. So prime factors of 3825 are 5 into 5 into 3 into 3 into 17. So now you can say these are not in proper order, not in increasing or decreasing order. As we already discussed in part 1, that fundamental theorem of arithmetic says order doesn't matter. So you can follow any order. So 3825 will be equals to 5 square. As you can see, 5 into 5 becomes 5 square. 3 into 3 becomes 3 square into 17. These are the prime factors of 3825. So pause the video and note it down. The next part, we have given number as 5005. So do the prime factorization of 5005. As you can see, the last number is 5. So we can directly divide it by 5. So this becomes 5 into 1001. So now divided by 7, it will become 143. Or you can say prime factors of 1001 is 7 into 143. Now 143 again can be divided by 11. So it will be 13. So 11 and 13 becomes 143. So now we have 5, 7, 11 and 13 as prime factors of 5005. So here the prime factors of 5005 will be 5 into 7 into 11 into 13. So all these are prime factors of 5005. So now next one, 7429. So 7429, when factorized we get 17 and 437. First prime factor of 7429 is 17 and another composite number is 437. So this 437 can be further factorized into 19 and 23. So we have three prime factors as 17, 19 and 23. So here the prime factor of 7429 are 17, 19 and 23. So you can do this work by dividing in the rough work or in your practice work. So Question number 2, we have find the LCM and HCF of the following pairs of integers and verify that LCM into HCF means product of LCM and HCF is equal to product of two numbers. So in the part 1 we have given numbers as 26 and 91. So here the prime factors of 26 are 2 and 13 and prime factors of 91 as 7 and 13. So here the HCF of 26 and 91 will be 13. You can see the common factor, highest common factor of 26 and 91 is 13. So HCF is 13. So and LCM of 26 and 91 will be 2 into 7 into common factor, that is 13. So 2, 7 and 13, that is 182. You can see 2 into 7 becomes 14 and 14 into 13 becomes 182. And you can do this multiplication with the help of Vedic maths, that is square the smallest number, that is 13. 13 square become 169 into 14 becomes 169 plus 13 you can do. So 169 plus 13 become 182. So very soon we will start the Vedic math series. So keep watching. So and now you can see HCF into HCF. HCF into LCM of numbers will be HCF we have 13 and LCM there as 182. So this will become 2366 and the product of numbers will be 26 into 91 becomes 2366. And with the help of Vedic maths you can do 26 100 times. Do the 100 times, not 91 times. Do directly 100 times. 26 into 100 becomes 2600. So now 2600 minus 26, do the 9 times, that is 234. So 2600 minus 234 becomes 2366. Or you can do this multiplication by your basic method in your practice work. So from equation 1 and 2 we have 1 and 2. You can see 2366, 2366. Thus we can say the product of HCF and LCM is equal to product of two numbers. So we have product of LCM and HCF as product of two numbers. So this is all about part number 1. Pause the video and note it down. The next part we have given number as 510 and 92. So do the prime factorization of 510 first. You can see here 510 divided by 2 becomes 255. Now 255 divided by 3 becomes 85 and 85 have two prime factors as 5 and 17. So we have two prime factors as 2, 3, 5 and 17. So prime factors of 510 are 2, 3, 5 and 17 and prime factors of 92 you all know 23, 4 are 92. So we can write as prime factors as 2 into 2 into 23. So HCF of 510 and 92 will be, you can see here 2 is only common factor to both numbers. So HCF is 2 and LCM of these numbers will be the highest power, that is first of all do 2 as common factor, then remaining 2 becomes 2 square, 3, 5, 17 and 23. So 2 square, 3, 5, 17 and 23. So this becomes 2 to the 4. 4, 5 is 20, 23 is 60. So 60 into 17 into 23. So now you can see 60 into 17 becomes 1020 and 23. So after multiplying you will get 23,460 as the LCM of given numbers. So now product of LCM and HCF will be 2 into 23,460. It will become 46,920. Give it equation number 1. Now the product of numbers, that is 510 and 92, will become 46,920. From equation 1 and 2 you can see we have verified that product of two numbers is equal to product of their HCF and their LCM. So this is all about part number 2. You can pause the video and note it down. So the next part, that is part number 3, we have given numbers as 336 and 54. So do the prime factorization of 336 first. So 336 divided by 2 become 168, 168 divided by 2 becomes 84, 84 divided by 2 become 42 and 42 divided by 2 becomes 21 and 21 divided by 3 becomes 7. So we have prime factors as 2, 2, 2, 2, 3 and 7. So right here prime factors of 336 is equal to 2 into 2 into 2 into 2 into 3 into 7. So this becomes 2 raised to power 4 into 3 into 7. And the prime factors of 54 is 2 3 is 6, 3 is 18, 3 is 54. So 2 into 3 raised to power 3. So HCF of these two numbers, that is 336 and 54, will be 2 3 is 6. You can see we have 2 as common factor and 3 as common factor from these. So 2 3 is 6 becomes HCF of the given numbers. Now LCM will be, you can see from here, highest least common multiple, that is with the highest power, that is 2 raised to power 4 is the highest common power in the both numbers. So 2 raised to power 4. Here highest power of 3 is 3 raised to power 3 and here 7. So the LCM will be 2 raised to power 4 becomes 16, 3 raised to power 3 becomes 27, and 7 will remain same. So after solving these numbers, you will get 3024 as the LCM of given numbers. So now product of HCF and LCM will become 6, and 6 multiplied by 3024 becomes 18144. Give it equation number 1. Now product of numbers will be 336 into 54. You will get 18144. That give it equation number 2. And you can do these multiplications in your practice work or rough notebook. Now you can see from equation 1 and 2, 18,144, 18,144, and in the left hand side you can see product of HCF and LCM and product of two numbers. Hence the statement is verified that the product of two numbers is equal to HCF and LCM. So we have verified that product of two numbers is equal to HCF into LCM. Pause the video and note it down. Next question, that is question number 3. Find the LCM and HCF of the following integers by applying the prime factorization method. So simply you already did this work in your previous class. Now we need to find only HCF and LCM of the given numbers. The first part we have given number as 12, 15 and 21. So prime factor of 12 are 2 into 2 into 3. So this becomes 2 square into 3. 15 can be written as 3 into 5 and 21 can be written as 3 into 7. So HCF of 12, 15 and 21 will be 3. 3, as you can see, 3, 3, 3 is the common factor to all numbers. So HCF will be 3 and LCM will be 2 square, then 3 is common factor, and 5 and 7. So this will be 2 to the 4, 4 3 is 12, 12 5 is 60, and 16 to 7 become 420. So the LCM of the given number is 420. This is all about the part number 1. You can pause the video and note it down. In the next part we have given number as 17, 23 and 29. So here the prime factor of 17, as 17 is prime number, so there is no other factor other than 1. So 17 into 1, 23 can be written as 23 into 1, 23 is also a prime number, 29 is also a prime number, so 29 can be written as 29 into 1. So HCF of these number is 1. There is no common factor other than 1. So HCF of these given prime numbers is 1. So and LCM of this number will be 17 into 23 into 29 into 1. So this will become 11,339. This is all about part number 2. In the next part, the given numbers are 8, 9 and 25. So here 8 can be written as 2 into 2 into 2. 2 to the 4, 4 to the 8. So this becomes 2 raised to power 3. 9 can be written as 3 into 3. So this can be written as 3 square. And 25 can be written as 5 into 5. So this will be 5 square. So HCF of 8, 9 and 25, you can see there is no common factor other than 1. So HCF will be 1. And LCM of this number will be 2 raised to power 3 into 3 raised to power 2 into 5 raised to power 2. So this will becomes 2 raised to power 3 becomes 2 into 2 into 2 become 8. 8 9 is 72 into 25 becomes 1800. So this is the LCM of given numbers 8, 9 and 25. So this is all about part number 3. So pause the video and note it down. So now next problem, that is question number 4. Given that HCF of 306 and 657 as 9, find the LCM of 306 and 657. Now we have given HCF, but now we need to find the LCM of given numbers. So we know that for any two numbers A and B, that is product of two numbers, that is A into B, will be equals to their LCM, that is LCM of A and B into HCF of two numbers, that is A and B. So this is the formula that we have already discussed in the basic of this chapter. So product of two numbers is equal to product of their LCM into their product of their HCF. So we have given number as 306 and 657. So write A as 306, B as 657, and we need to find LCM. So LCM of 306 and 657 will be here, and HCF of 306 and 657, but we have given already HCF as 9. So write it here. HCF of 306 and 657 as already given, that is 9. So transpose this 9 to the left hand side and become LCM of 306 into 657 is equals to 306 into 657 divided by 9. So this will be 9 into 34 becomes 306. So 306 can be cancelled with 9 on 34. Now 34 multiplied by 657 becomes 22,338. So this is all about question number 4. Pause the video and note it down. The next problem, that is question number 5. We have to check whether 6 raised to power n can end with the digit 0 for any natural number n. So 6 raised to n can end with 0 only when 6 has its prime factor as 2 and 5. You all know any number can end with digit 0 if it has its prime factor as 2 and 5. So, but we know that 6 has its prime factors as 2 and 3 only. There is no prime factor as 2 and 5. We have 2 but not 5. So 6 raised to n can never end with digit 0. So this is all about question number 5. So now proceed for question number 6. Explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite numbers. We have already studied about the composite number in the basic of this chapter. That is that a composite number have 2 or more than 2 factors other than 1. So here we already studied. So as composite number have 2 or more than 2 factors other than 1, here we have 7 into 11 into 13 plus 13 as 13 into 7 into 11 plus 1 has 2 factors as 7 into 11 plus 1 and 1 and 13. As it has 2 factors other than 1, therefore it is a composite number. By the definition, it is composite number. Similarly, 7, 6, 5, 4, 3, 2 and 1 plus 5. So we can take 5 as common from these two terms. So 5 into, it becomes 5 into 7 into 6 into 4 into 3 into 2 into 1 plus 1. So this factor can further factorize, but we need not to factorize it. So thus the given number has factors as 5 into 7, 6, 4, 3, 2 into 1 plus 1 other than 1. So it is composite number. As you can see, this number has more than 2 factors. So this is composite number. This is all about question number 6. So you can pause the video and note it down. And the last problem of this exercise is question number 7. There is a circular path around a sports field. Sonia takes 18 minutes to drive one round of field while Ravi takes 12 minutes for the same. Suppose they both start at the same point and at the same time and go in the same direction. After how many minutes will they meet again at the starting point? So here we need to find the after how many minutes they meet again. We will have to find the least common multiple of 18 and 12. That is, we need to find the LCM of 18 and 12. So 18 can be written as 2 into 3 into 3. So 2 3 is 6, 6 3 is 18. So 2 into 3 square we can write it as. And similarly 12 can be written as 2 2 is 4, 3 is 12. So 2 into 2 into 3. So 2 square into 3. So LCM of 18 and 12 will be 2 square into 3 square. That will be 4 into 9 and that is 36. So after 36 minutes they will meet again. So hence after 36 minutes they will meet again at the starting point. So this is all about exercise 1.2. If you learn from this video, then you can subscribe my channel and share this video as much as you can. Thanks for watching.